Hi everyone, welcome back. Let's continue. What is the study of statistics? Statistics is the science of collecting, organizing, summarizing, analyzing, and interpreting the data to draw conclusions. There are two types of data sets we will use when studying statistics. First, population. Population is a particular group of interest that a statistical study centers on. For examples are Indiana Tech students. Okay, sample is a subset of a population. For example, students in our class. Alright, let's look at example 4. A quality control manager randomly selects 50 bottles of Coca-Cola that were filled on October 15 to assess the calibrations of the filling machine. So what's the population? Population is like all bottles of Coca-Cola. And the sample is the 50 bottles of Coca-Cola. It is a subset of the population. Alright. And then the next following two terms are used throughout the course. First, parameter. Parameter is a number used to describe a population characteristic. So what is population characteristic of interest? This is like a GPA. For example, if the population is all Indiana Tech students, the parameter, which is like the characteristic of interest, it could be the GPA, the number of credit hours, and credit hours, or hours of work per week. So some of you are doing the part-time job, so hours of work per week, or your major, or whether you are left-handed or right-handed. Okay, so it's not necessary just numbers, it could be other informations. Okay. And characteristic is a number used to describe a sample characteristic. So statistic, this is called statistic. So we have the population parameter and we have the sample statistics. Okay, so they're all about characteristic of interest, but for population we use parameter, and for sample we use the word statistic. Alright, let's look at example 5. Decide whether the numerical value describes a population parameter or a sample statistic. Part A. A recent survey of a sample of 128 Indiana Tech students reported that the average number of hours worked per week for full-time students at Indiana Tech is more than 15 hours. So what is this? Do you see the keywords? This is a sample. Well, sample, then this is a sample statistic. So we write down sample statistic. Next, in a recent year, the average math score for all graduates on the SAT was 523. What's the keyword? All graduates. All. So this is the entire population. So this is population parameter. Okay, everyone? So we want to look for the important words. Such as samples or, okay? Let's continue. Given a sample of n measurements or observations x1, x2, x3, blah blah blah, xn, the sample mean is 1 over n times the sum of all the xi's. So here we have n numbers. So see here we have n numbers. So the sample mean is really like the average. You add them all up and then divide it by n. So this is like the average. Okay, but we call it sample mean. Next, order the n observations from smallest to largest. Then what is the median? The median, if n is odd, okay, so if n is odd, we order from the smallest to the largest, okay? And if n is odd, the median is the middle, okay? That's the middle one. So middle is the observations in position n plus 1 over 2. For example, here we have 5 number, right? The middle one would be the third one. So that's why n is 5. 5 plus 1, 6. 6 divided by 2 is 3. So you see it match with our formula. Okay. What if n is even? Well, when n is even, of course, you want to order it from smallest to largest. But there is a middle 2. There's no middle 1, but there are 2 in the middle. Then what you do is you take the average of those middle 2. So if n is even, for example, if n is 6, then the third and the fourth one are the middle ones. So that's why the average of observation in position n over 2, which is 6 over 2 is 3. N plus 2, which is 8 over 2 is 4. So you see, it matched the formula. So we have the middle 2, and we take the average of those two numbers. Measurements measures such as sample mean and median describe the middle or average of data, but they don't tell us how the values deviate from their mean. So that's why we look at the difference. So we have the mean, which is the x bar. This is the mean, sample mean. The difference, x1 minus sample mean, x2 minus sample mean, etc. xn minus sample mean are called deviations from the mean. So all these differences are called deviations from the mean. And then what is the sample variance? Well, sample variance, we denote as squared. That is 1 over n minus 1 times the sum of all those differences squared. Okay. In order to have the square, we can use square or absolute value, because you want to talk about the difference. Well, you want to take the absolute value or square so that all the difference is like positive. When you add them all up, you don't want the differences to cancel, right? So, but there are good reasons why we use the square instead of absolute value. For example, we can differentiate square, but we cannot differentiate absolute value function, right? So that's why we use the square. And why do we divide it by n minus 1? There are n differences. Why do we divide it by n minus 1 instead of n? The reason for dividing by n minus 1 instead of n is that there are only n minus 1 independent deviations xi minus x bar. Why n minus 1? Well, because here it's like we have n variables, but there is a one relations among them. The relation is when we add them all up. You see, when we add them all up, we can distribute the sum. So we get sum of xi minus sum of x bar equals, here you can see, because this is a constant, so we're adding this guy n times, right? So that's why it equals n times x bar. And remember this guy, this is actually our sample mean equals 1 over n times the sum. So that's why this sum is n times x bar, right? So that's why we get them cancel and we have 0. So that's why they have a relations. So we can express one of them in terms of the others. So we get linear combinations of the other variables. So here we have m minus 1 independent variables, deviations. And then the remaining one depends on these n minus 1 deviations. Okay? Alright, so that is sample variance. You might ask, why do we call it S squared? Well, because we use S. And what is S? So the standard deviation is the S. So S is the square root of the sample variance. Alright. So, okay. Let's look at some example. Example 6. Given the numbers 15, 14, 2, 27, 13. Part A, find the mean. Part B, find the median. Part C, find the standard deviation. Okay. Part A, what is the mean? So the mean is we add them up. So we add them all up. 15 plus 14 plus 2 plus 27 plus 13. And we divide it by 5 because we have 5 numbers here. So n is 5. Okay, what is this? So here I have my calculator. You can also use your calculator. Okay, so everyone please pause the video here and try to work on it. Okay, and then you can continue to play the video to check your answers. So let's see. Let me make this smaller. Okay, so we have 15 plus 14 plus 2 plus 27 plus 13. Parentheses divided by 5. Do you see 14.2 is the answer? That's the mean. 14.2. Okay, part B, median. Median. First, we need to order the data from smallest to largest. So the smallest is 2, and then we have 13, 14, 15, 27. Right? And which one is the middle guy? This guy is the middle guy. So the median is 14. Okay, so part C, what is the standard deviation? Well, first of all, we need to compute the variance. And so variance is 1 over n minus 1. So n is 5, n minus 1 is 5 minus 1. And then we use the first number minus the mean square plus the second number minus the mean square plus next number minus the mean square plus 27 minus the mean square plus 30 minus the mean square. So in the exam or your homework, you need to show all your work. So you have to show all these. Okay, you need to write down how you calculate it. You cannot just give me the answer because your calculator can tell you the answer right away, but you have to show your work to let me know you understand how to do it. So 15 minus 14.2 is 0.8. And then this is minus 0.2, but negative square become positive. So we can just put 0.2 squared. Here we get negative 12.2, but the negative square just become positive. And 27 minus that is 12.8. And here we get 1.2 squared. Okay, so let's see. Okay, let's see. We put this in our calculator. Parentheses, and then we have 0.8 square plus 0.2 square plus 12.2 square plus 12.8 square plus 1.2 square, close parentheses, divided by 4. Okay, 78.7. And we haven't finished because this is a sample variance. Then the standard deviation. Okay, so standard deviation S is the square root of the sample variance. Well, what is square root of that? You can put square root of our answer, which is 8.8713. So this is the standard deviation. So far so good, everyone. It's approximately equal to. Okay, so in the exam you need to show all your work. Okay, show all your work. Otherwise, no credit. Okay, and let me teach you. So you can actually get the mean and standard deviations and variance directly from your calculator. Okay, if you input the data. And let me show you how to do it. So take out your calculator. So every student might have a different calculators. Okay, so here I'm gonna show you two videos of two types of calculator. Okay, so okay. Alright, so let me see. Okay, so if you go to our course website, do you see this videos how to use your calculator? And here, mean and standard deviation example 1, mean and standard deviation example 2. So when you click the example 1, you see this video. So let's check out together.
Hi everyone! In this video, I want to show you how to use your calculator to find the mean and variance standard deviation of a sample data. Okay, so first of all, you go to data, and then if you already have something, just delete all of them. Okay, so you input the data. So we have 27. Let me put here. So 27. 36, 18, 23, 29, 54, 39, 41, 16, 37, 29, 33, 51, 35, 37, 13, 21, 17, 22, and 20. Okay, so we have 20 numbers. And then my calculator, you see the stats. This green color means we need to plus the second and plus stats. You see, it's one variable stats or two variables. So here we only have the x values. So this is one variable stats. If we're doing regression line, which is in chapter 11, we have two variable stats. Okay, so enter, and we're calculating the first column. Okay, so here we are. You see the x bar. The x bar is the sample mean is 29.9. So 29.9, and you see Sx. So this is the standard deviation, the sample standard deviation. So 11.4474. Okay, so you actually go down and you see more. So This sigma is the population standard deviation. So S is the sample standard deviation. Well, the difference, remember the difference between sample variance and the population variance is the sample variance you divide it by n-1 because there are n-1 independent variables. But for the population standard deviation, we divide it by n. Okay, so this is how we find the sample mean and the sample standard deviation given a set of data.
Alright, so let's look at the second type of calculator.
Hi, I'm going to tell you how to use our calculator to find the mean and sample variance standard deviation. So turn on the calculator and we press mode. Then you can see the stats. So press 3, then press one variable. So one variable, then we can see the column. Let's input our data. So we have 15, and then 14, then 2, then 27, then 13. Okay, after we input the data, so can you see the shifts and stats? So if we press shifts and stats, we can only see there are 3 options. This is not what we want. So press AC. So go back to this page and then press shift and 1. You see 6 options. So you have to press AC, then shift and 1. Then you can see the 6 options. To find the sample mean and standard deviation, you need press 4. So press 4, and you can see when you press 2, you will see the sample mean. Press enter, you get the sample mean of these 5 numbers is 14.2, the same as our in-class example. And when you go back, clear, and then shifts and 1, you get that, and go to 4. Now we want to press SX. So this means the standard deviation using the formula this is divided by n-1, where this sigma x means we have the standard deviation, the formula is divided by n, so we don't want to use this one. We want to use this number 4. So we press number 4 and enter. This is the same number as we got in our in-class example. This is the standard deviation. Okay, if you have any questions, feel free to come to my office hours or email me. Thank you. Have a good weekend.
Okay, so that is how to use your calculator to get the mean and standard deviations. Because your calculator can get the numbers directly, so that's why you need to show all your work. Alright, in order to receive credits. Okay, so please pause the video and try to work on example 7. Okay, have you finished? Let's check our work together. So part A, find the mean. So find the mean x bar equals, so we add all the numbers. And then divided by, what is n? We have 6 numbers here. Okay, so let's see. Let me make this smaller. So calculator here. So we have 11 plus 9 plus 17 plus 19 plus 4 plus 15, and then divided by 6. We get 12.5. So this is the sample mean. Part B, find the median. Median, don't forget, we need to order the data. from smallest to largest. Smallest is 4, and then 9, 11, 15, 17, 19. So we have the middle two. So the middle two, we want to take the average. So average is 11 plus 15, and then divided by 2. We get what? So that's 26 divided by 2, which is 13. So 13 is the median. Okay, part C, we want to find the standard deviation. Standard deviation, first of all, we want to compute the sample variance. So sample variance is 1 over n minus 1. So 6 minus 1. And then each data, so 11 minus the mean square. 9 minus the mean square. 17 minus the mean square. 19 minus the mean square. And 4 minus the mean square. And 15 minus the mean square. Well, that's a lot to plug in the calculator. So before I plug in the calculator, I want to simplify. Okay? And here 11 minus 12.5 is negative 1.5, but negative square become positive. And the 9 minus that is negative 3.5 square become positive. And this guy, we have 4.5 square. Here, 6.5 square. Here, 8.5 square. And that is 2.5 square. Okay, now let's put this in our calculator. We have, let's see, 1.5 square plus 3.5 square plus 4.5 square plus 6.5 square plus 8.5 square plus 2.5 square. Okay? And then divided by 5. Do you get 31.1? Okay, so this is the variance. And then what is the standard deviation? Standard deviation is the square root of the sample variance. And that is square root of 31.1. We get 5.5767. Okay? So you can use your calculator and enter the data and then find the mean and variance to check your work. So this is the good thing about this kind of examples. You can use your calculator to check your work. If you get the same answer, awesome. You get other points. If you get different answers, you know there is some mistake. And then go back and check your work. Maybe you forgot to order the data. Maybe you do some calculation. There is some mistakes inside. Okay? So, but you can always know whether you're doing right or wrong on this type of problems. Okay, so if you have any questions, feel free to ask me. Have a nice day. Bye.